So when we say it's left recursive is if it is immediately present on the right hand side. The same noun terminal, whatever it is there on the left hand side, if it's immediately present on the right hand side, we say the given grammar is left recursive. Now how do we eliminate it? Why left recursive grammars are a bad property of a top-down parser? So we have to eliminate left recursion and make it right recursive for parsing. Now what is the procedure to eliminate left recursion? How do you eliminate it? Now the same product grammar we take it, A gives A alpha or beta. We replace this grammar production A gives A alpha or beta by a two productions. How do you replace it is? Now let us take it. We have two terms, two alternatives, which means A can be replaced by A alpha or A can be replaced by beta. There are two terms. Out of these two terms, one term is creating recursion. What is creation recursion? The term which is present on the immediately on the, like here A is immediately present on the right hand side. We say A alpha is the term which is creating recursion. Now take the other term which is not creating recursion, which is beta here. How do you, I am talking about the procedure, how to eliminate left recursion. Now take the term which is not creating recursion. Here the term here is beta. Now replace the term A gives A alpha or beta by A within set of new productions as A gives beta, the term which is not creating recursion, and the term which is creating recursion we replace with a new variable. Okay, now here new variable we are taking here is A dash. It can be B, it can be Z, whichever the symbols that is not there in the existing grammar. Take the symbol, take the variable which is not present in the given grammar. Now here I am taking a new variable as new symbol as A dash. Now A gives A alpha or beta is replaced by a production A gives beta A dash. The term which is not creating recursion beta, and the term which is creating recursion we are replacing with a new variable called A dash. Now we have to expand, we have to write what is A dash. A dash gives, what is there, don't write the symbol which is creating recursion. A is the symbol, A is the variable which is creating recursion. Don't write A. Now write the leftover symbols after A in the term. Here there are only two symbols A and alpha. As A is creating recursion, write the next symbol which is alpha only. We have only alpha and the variable that you have created A dash. A gives alpha A dash or epsilon. Yeah, so we have created a new variable called A dash. A dash gives A dash, alpha A dash or epsilon. This is the process that we eliminate recursion in a given grammar. Now let us work out with some examples. This is the process. We have a production A gives A alpha or beta. We write down, take the term which is not creating recursion. Beta is the term which is not creating recursion and A alpha is the creating recursion. Now in place of A alpha we write simply A dash. Now A dash we have to expand A dash. A dash gives the symbols which are left over, don't write A. All the symbols which are left over in this term you write down here. Alpha is the only symbol which is left over, alpha, and the variable you have created A dash slash epsilon. This is how you eliminate left recursion in a given grammar. Now let us work it out with an example 1. Take it here, we have a production given here. A gives A dash. So after eliminating recursion, left recursion, we got this grammar. Now there are two terms, A gives A B and A gives C. So there are two terms here. One is A gives AB and A can be replaced with C. Now out of these two terms, A gives AB is creating a recursion and A gives C is not creating a recursion. So when we say recursion, immediately the same non-terminal A is immediately present on the right hand side. We say it's recursive. So out of these two terms, one term is creating recursion and the other term is not creating recursion. So how do you eliminate it is, we write it here A, the term which is not creating recursion, the term which is not creating recursion, so we take that, means A gives C A, C, the term which is not creating recursion is C, and the term which is creating recursion AB as A dash. You can take it X or Y or Z, which is not mentioned in the given grammar. Now I am taking a variable called A dash, new variable. Now that new variable has to be expanded. So how do you expand? A dash gives, in what place you have created A dash? In place of AB, you have created a new variable called A dash. Now you have to write down what is this A dash. A dash gives, don't write A because it's creating recursion. Take out all the symbols after A. So what are the symbols that are after A? We have only B. Only B, and the variable you have created, you have to write down A dash slash epsilon. So this is how you eliminate left recursion from the given grammar. The same thing we have here, example 2. Okay, now there are three terms for a given production. A gives AB is one term, A gives AC is another term, A gives D is another. There are three terms in a given production. Now how do you eliminate here is, out of these three terms, two terms are creating recursion, right? Now replace these two terms by a new variable called A dash. You can take it any variable. I have taken a new variable called A. The term which is not creating recursion is only one. Write down. Now the new productions are, A gives, write the term which is not creating recursion, which is D, and the term which is creating recursion, we are creating a new variable called A dash. Now what is this A dash? A dash gives, don't write the term which is creating recursion, variable symbol here. So ABAC, so in place of ABAC what we write it? We write it only B, and we write it only B A dash, the symbol we have created, and C A dash, the symbol we have created slash epsilon. So this is how you eliminate left recursion from the given grammar. Now take it another example. Yeah, now here in this production we have so in this we have two terms which are creating recursion and one term which is not creating. The same thing we do it. S gives, the term which is not creating recursion we take it C, and the terms which are creating recursion we take it as X, replacing the term by X. In the previous examples we have taken as A dash. You can take it out any variable which is not mentioned in the given grammar. Now the new variable X is what? A. Now the two terms which are creating recursion is, one is SC and other is SB. Now don't write S because the same variable. In place of S, what are symbols that are there in the term A, and followed by, you have created a new variable called X slash epsilon. In the same thing we have another term called SB. So SB means we don't write S, B, and create whatever variable you have created X slash epsilon. We are writing epsilon once only. So this is how you eliminate left recursive. By looking at the production, left recursive grammars are a bad property of top-down parsers. So we have to eliminate. One of the pre-processing that we have to do it while giving to top-down parser is, we have to eliminate left recursion. We have seen what is left recursion and how to eliminate it.